All right, here's my presentation for video 4. This is based on, train systems. So here is a train stopper used at the end of railroad tracks or in places like Ogilvie Station or Union Stations, where you commonly are going to see them. Um, they're basically in place to stop the train from continuing past, the railroad track when there's no more track left. Um, and so they use these giant pins that can press into the stand, basically slow the cars down and stop them and prevent, them going past where you want them and prevent any damage from happening. Similar systems is a bit of an older train car. Basically the same system acting, but a little bit smaller on each side here because this is back when, um, you know, technology wasn't as great, and so and the brakes weren't as good, so again, coupling systems were different. So basically, what they would use sometimes, what would happen is these train cars would basically just run into each other. And you don't want solid bodies running into each other with no compression system because, you know, that's how stuff's going to break, especially with, 100 or 1,000-ton train cars running into each other. So a bit that, these little pins compress into the train car, and same thing would happen on the other train car, slowing them down and stopping them and preventing, any damage occurring. So here's our model. Here we have a little train engine pushing the train along. Here's our one train car. Here's our second train car, and here's those two hydraulic pins, um, acting to slow those train cars down from hitting each other. And then, we have this train stop here, acting at the end of the line, that this is also hitting. So you can imagine, engine connected to this train car. We can assume that this is one solid body. This is running into this train car. They're compressing together, and this train car is running into the end of the line stopper, which is compressing that, this large pin that we see here. So we're assuming this is one mass. We're assuming this is another mass. We're assuming these are both equal dampers, and then we're assuming this is another damper. So that's how our equations are going to go. And our one equation is going to be for this mass, which is going to have this damper acting on it and these two equal dampers acting on it. And so because these two are equal and they're both basically doing the same thing, we can kind of just consider them as one. That's how it's going to end up in our equation. And then here is our other mass. We can say that this is a force because we do have you know, our train engine kind of driving this mass into the other one. But this is only going to have this damping system acting on it instead of both. And again, these two are the same, doing the same thing. They're just going to compound and just come out to one damping system. But yeah, so that's my train model. That's kind of a real life situation of how this could be used in the real world. It's a little less modern because modern trains don't use these pin systems anymore. The braking systems are better. They have more advanced technology systems for coupling. The couplers are completely different. Um, but yeah, there's my video.